signals from alien civilizations. So the question is, should we expect to? The Fermi Paradox, is anyone familiar with this phrase? The Fermi Paradox? I mean, I'll explain it anyway. I'm just curious as to who's heard of it. So this relates to essentially a conversation, a lunchtime conversation in 1950 amongst physicists at the Los Alamos laboratory in the United States, and they were trying to build a hydrogen bomb. Bear that in mind because it's maybe relevant later. And this conversation turned to life in the universe, and someone made the comment, there are so many stars, so many planets, the life in the universe must be full of life. And so Enrico Fermi, who was one of the physicists there, asked this question, well, if they're there, where are they? I mean, if life is so common, where is it? And this has become known as the Fermi Paradox. Now, of course, it's only a paradox that we don't find any alien life if alien life is indeed common. I mean, it's only a paradox based on the presupposition that alien life must be common and we don't see it, therefore it's a paradox. If alien life is not common, if we are alone in the universe, then of course this is not a paradox, it's a simple question. Where are the aliens? And we don't see them. And the answer is we don't see them because they're not there. So whether it's a paradox or just a simple question, with a negative answer, it's my purpose to explore that in this talk. So how do I advance the slide? Maybe if I click that one. Okay. Strange, because they worked before, these buttons. All right. Okay. So now the Fermi paradox, or the Fermi question, has become increasingly pressing of late because we have at least discovered that other planets are common in the universe. And so insofar as planets, you might think planets are a prerequisite for life and life a prerequisite for intelligent life, then at least we've got lots of planets. So I don't know whether anyone recognizes this part of the sky. Anyone recognize this part of the sky? Some famous stars in this image. Of course, it's not a part of the sky you can see from London. It is the Southern Cross. So this is the southern Milky Way. This is the Southern Cross here. And this is Alpha Centauri, which is our nearest star, 4 light years away. And all the stars in the background are in the Milky Way. And of course, this is the pulsar, which is a dark interstellar dust cloud blocking out some of the background stars. So what we've learned since 1995, when we first discovered planets orbiting another solar type star, is that planets are really, really common. In fact, now the statistics are now such that we would expect almost all stars to have planets. So that means that all the stars in this image, I mean, to a first approximation anyway, not just the bright ones, but all of these the billions and billions of little stars in the background, which are, and they're only faint because they're a long way away, they probably all have planets. So this means there are a great many planets in the universe. And so you might think a great many places where life could originate and evolve. And if that's true, then Fermi's question comes back. Well, where are they? Why have we seen no evidence of them? Just something else I'd like you to bear in mind. If I don't remember anything else from this talk, you might like to remember this. We also know something about the ages of stars, and therefore the ages of the planetary systems that orbit them. And the average age of rocky planets, Earth-like planets in the galaxy, the average age is about 7 billion years. Now, the age of the Earth is 4.5 billion. So this means the average planet, the average rocky planet in the galaxy, is 2.5 billion years older than the planet we're living on. So that means if life was common in the universe, then there's been plenty of time for life to have got started before it got started here, billions of years in advance of us. So Fermi's question comes back if this is true. If the average age of planets is so old, and the average age of life is so old, and the average age of intelligent life is so old, shouldn't this intelligent technological life that evolved in the deep history of the galaxy, shouldn't it have been doing stuff that we would have noticed? And we haven't, and this really is also part of Fermi's question. And this is much deeper than just the fact we haven't detected anything with radio telescopes. SETI is predicated on finding intelligent civilizations transmitting radio waves that exist in the here and now. And the chances of existing relatively nearby at the present time to an alien civilization comparably advanced to our own, all at the same time, this is really minuscule. Technological civilizations would have to be extremely common for us to be coexisting relatively close to another one, and that may go some way to explaining why SETI hasn't detected anything. But that doesn't really address Fermi's paradox in its strongest form, because Fermi's paradox can also ask about the history of the galaxy. If these technically capable species existed in the deep history of the galaxy, they've had plenty of time to be doing stuff that we should have noticed by now if they were really common. That at least is the argument. The original, and this was the sense in which so in order to address Fermi's paradox specifically, I mean, I could love to get into SETI and other aspects of astrobiology, and perhaps we'll have time to do that in the Q&A. But since I've only got 45 minutes or something, then I'm going to address Fermi's paradox in its original form and present to you some of the suggestions that have been made for its solution. So the original and strongest form of Fermi's paradox relates to the absence of evidence of extraterrestrial intelligence, that's ETI, on Earth today, and the apparent lack of interference with biological evolution on the Earth throughout the last 4 billion years that we have been here. The Earth has been here, but the galaxy, of course, is much, much older. So here is a paper published in one of the journals of this society. I'm afraid it's a journal that doesn't exist anymore. The Quarterly Journal of the Royal Astronomical Society. The universe appeared in the pages of the Quarterly Journal of the RAS, including this that has now become a classic paper by Michael Hart, 1975. And this is his title, An Explanation for the Absence of Extraterrestrials on Earth. Now I'll jump forward to his explanation, and his explanation is that they're not here because they don't exist. And I'm afraid, spoiler alert, I'm going to come to much the same conclusion. But what I'm going to do is try and work through these arguments. So in his paper, Hart, 1975, drew attention to the sentence I've extracted here.